Welcome back to G Fun Facts Online. Today, we are going to look up at the southern sky, past the familiar constellations, to talk about a deception that has lasted for billions of years. To the unaided eye, the night sky looks peaceful. It looks static. We see points of light that have guided sailors and inspired poets for millennia, and we assume they are just fixed stars. But that tranquility is an illusion. Beneath the velvet stillness lies a universe of violence and velocity, where galaxies cannibalize their neighbors and gravity sculpts the fabric of space-time itself. Nowhere is this deception more profound, or perhaps more beautiful, than in the constellation of Centauri, where a specific object, known as Omega Centauri, has been hiding a dark secret. For centuries, astronomers thought Omega Centauri was just a star. In fact, nearly 2,000 years ago, the ancient astronomer Ptolemy catalogued it as a single star. It wasn't until 1677 that Edmund Halley, the man famous for the comet, looked at it from the island of St. Helena and realized it was actually a nebula. Later, with better telescopes, John Herschel realized it was a globular cluster, a tight ball of millions of stars. But in the mid-2020s, a team of researchers pulled back the final veil to reveal the truth. Omega Centauri is neither a star nor a normal cluster. It is the skeletal remains of a dead galaxy. And locked within its heart, anchoring the chaotic swirl of 10 million suns, lies one of the most elusive objects in astrophysics, an intermediate mass black hole. This is a detective story spanning 2 decades of data from the Hubble Space Telescope. It involves millions of measurements, 7 runaway stars, and the confirmation of a missing link that bridges the gap between the stellar graveyards and the monsters that rule the galaxies. So let's dive into the details. To really understand why this discovery is so huge, we first have to understand the object itself. Omega Centauri is the largest, brightest, and most massive globular cluster in our Milky Way galaxy. It sits about 17,700 light-years from Earth. It is so big that you can see it with the naked eye as a fuzzy blob. But Omega Centauri has always been the odd one out. A typical globular cluster is basically a retirement home for stars. It's usually a collection of a few 100,000 stars that were all born at roughly the same time, from the same gas cloud. They are cosmic time capsules that preserve the chemistry of the early universe. Omega Centauri breaks every single one of those rules. It is 10 times more massive than a typical cluster. It contains nearly 10 million stars packed into a sphere only 150 light-years across. In its core, the stars are so densely packed that they are separated by only a fraction of a light-year. If you lived on a planet, orbiting a star, in the center of Omega Centauri, your night sky would not be black. It would be a blazing white roof of diamonds, shining with the intensity of 1,000 full moons. But more puzzling than its size is its complexity. Unlike normal clusters, the stars here are not all the same age. They possess different metallicities, which is astronomer speak, for the abundance of elements heavier than hydrogen and helium. This implies that Omega Centauri didn't just form once and stop. It had multiple bursts of star formation over billions of years. It sustained itself. It evolved. For decades, this anomaly led astronomers to a radical hypothesis. Omega Centauri is not a globular cluster at all. It is the stripped nucleus of a dwarf galaxy. The theory goes like this. Billions of years ago, a small galaxy, let's call it the Omega Galaxy, ventured too close to the Milky Way. Our galaxy is far more massive, so it ensnared the intruder in its gravitational web. As the Omega Galaxy plunged through the Milky Way, tidal forces stripped away its outer spiral arms, its gas, and its dark matter halo. All that remained was the dense, tightly bound core, the nuclear bulge. This core, battered and naked, settled into an orbit around the Milky Way, a fossil of a galactic meal. If this theory is true, then Omega Centauri should look like the center of a galaxy, and the centers of galaxies are known for one thing above all else: they house black holes. This brings us to the physics problem, the Great Mass Gap. Black holes are the universe's most extreme objects. For a long time, astronomers have comfortably categorized them into 2 distinct families. On the lighter end, we have stellar mass black holes. These are the corpses of massive stars. When a star about 20 times the mass of the Sun runs out of fuel, it collapses and leaves behind a black hole weighing between 5 and 100 solar masses. We see these everywhere. On the heavier end, we have supermassive black holes. These are the monsters weighing millions or billions of solar masses, sitting at the centers of large galaxies, like Sagittarius A in our own Milky Way. But there is a problem. A massive chasm exists between these 2 groups. We see black holes that are 10 times the mass of the Sun, and we see black holes that are 10 million times the mass of the Sun. But historically, we found almost nothing in between. This is the intermediate mass black hole gap. An IMBH would weigh somewhere between 100 and 100,000 solar masses. The absence of these middle weights creates a chicken or the egg problem for cosmology. How did the supermassive monsters get so big? Did they start small and eat their way up? If so, we should see these teenagers, these intermediate ones. Finding an IMBH is like finding a missing link in human evolution. It proves that the monsters didn't just appear by magic, they grew. And the best place to hide a medium-sized black hole is in the center of a medium-sized object, like the stripped core of a dwarf galaxy, Omega Centauri. The hunt for this black hole has been a roller coaster. In 2008, a team led by Eva Noyola claimed they found evidence of a 40,000 solar mass black hole using Hubble data. But the scientific community pushed back. In 2010, another team argued that the center of the cluster wasn't where Noyola thought it was, and that the star movements could be explained without a black hole. The debate stalled because of crowding. The stars in the center are so packed that even Hubble struggled to distinguish individual movements over short periods. To settle the debate, astronomers needed something better than a snapshot. They needed a movie. Enter Maximilian Haberle. In 2024, Haberle, a PhD student at the Max Planck Institute for Astronomy, led a team that performed one of the most exhaustive data analyses in the history of cluster astronomy. They didn't just take a new picture, they dug into the archives. They compiled over 500 images of Omega Centauri taken by Hubble over a span of 20 years. These images were originally taken for different purposes, mostly to calibrate instruments, but by stitching them together, the team created a timeline. Their goal was to measure the proper motion of the stars. Usually, astronomers measure velocity by looking at redshift or blueshift, which tells you if a star is moving towards or away from you. But that doesn't tell you how a star is moving across the sky. Proper motion does. By meticulously aligning images from 2002 to 2024, the team tracked the tiny shifts in position of 1.4 million individual stars. It was a monumental computational task, akin to tracking the movement of a million individual gnats in a swarm from miles away. They were looking for fast movers. In a gravitationally bound system like a star cluster, there is a speed limit called the escape velocity. If a star moves faster than this limit, it should fly out of the cluster and disappear. If there is no black hole, the stars in the core should be moving randomly but staying below a certain speed. However, if there is a massive invisible anchor in the center, stars close to it will be whipped into a frenzy. They will orbit the invisible point at breakneck speeds. Haberle's code sifted through the 1.4 million tracks and flagged something extraordinary. 7 stars. Deep in the innermost region of the cluster, right where the density is highest, 7 stars were moving significantly faster than they should be. These were not subtle anomalies. They were screaming across the core. Haberle explained that these stars are moving so fast that they should escape the cluster and never come back. But they hadn't escaped. They were still there, caught in a tight, frantic dance. The fact that they were confined to the center meant something was holding them, something with immense gravity. The team ran the numbers to calculate the mass required to keep these 7 high-velocity stars in orbit without letting them fly apart. The result was specific and undeniable. At least 200 solar masses, the only object that can pack 200 times the mass of the Sun into a region smaller than our solar system, without emitting light, is a black hole. This wasn't a statistical guess. This was kinematic proof. Just as we proved the existence of the supermassive black hole in our own Milky Way by watching stars orbit an empty point in space, Haberle's team had done the same for Omega Centauri. They had found the anchor. This confirmation changes our understanding of Omega Centauri from a curiosity to a cornerstone of galactic history. It confirms the stripped nucleus theory. A simple globular cluster formed from a gas cloud has no mechanism to create such a massive black hole. A black hole of this size forms in the chaotic, high-density environment of a galactic core. Omega Centauri is a fossil. It is a frozen galaxy. Imagine the timeline. 10 billion years ago, the Omega Galaxy was a thriving dwarf galaxy, perhaps similar to the Large Magellanic Cloud. It had gas, dust, star formation, and a central black hole that was slowly growing. It was an IMBH, on its way to becoming supermassive. Then came the collision. As it fell into the Milky Way, our galaxy's gravity stripped away the fuel. The gas was siphoned off. The star formation stopped. The outer stars were peeled away. The central black hole was starved. Without gas to eat, it stopped growing. It was locked in time, stuck at around 8,000 solar masses, while its cousins in undisturbed galaxies gorged themselves and grew into the giants we see today. For astronomers, this is better than finding a supermassive black hole. This is finding a seed. By studying Omega Centauri's black hole, we are looking at the baby pictures of the monsters that rule the universe. One of the interesting things about this discovery is how quiet the black hole is. Following the discovery, other teams looked for radio waves coming from the center. Black holes do not emit light, but the material falling into them usually screams in X-rays and radio waves. But the search came up empty. It is radio silent. This actually fits the stripped nucleus model perfectly. Globular clusters are gas poor. The gas was blown out billions of years ago. There is nothing left for the black hole to eat. It is a dormant beast, sitting in the dark, revealing its presence only by the terrifying speed of the stars that dare to venture too close. The discovery of these 7 fast stars is just the beginning. The 8200 solar mass figure is a lower limit. We only see the motion of the stars across the sky, which is 2D motion. We don't yet know their full 3D velocity. To get the full picture, astronomers are using the James Webb Space Telescope. Webb's sensitive instruments will measure the radial velocities of these faint stars deep in the glare of the core. When we combine the Hubble proper motions with the James Webb radial velocities, we will have full 3D orbits. We might find that the black hole is actually larger, perhaps 20,000 or 30,000 solar masses. Furthermore, the upcoming extremely large telescope in the Atacama Desert will have the resolution to see even closer to the event horizon. For thousands of years, humans have looked up at the southern sky and seen a fuzzy star. We named it Omega Centauri. We charted it for navigation. We admired its beauty. We had no idea that we were looking at the corpse of a galaxy. We had no idea that in the heart of that shimmering jewel, a monster was lurking. Not a titan like the one in the center of our galaxy, but a rare, medium-sized predator, frozen in a state of arrested development. The discovery of the intermediate mass black hole in Omega Centauri is a triumph of patience. It required 20 years of staring at the same spot, waiting for the stars to move just a fraction of a pixel. The fast stars of Omega Centauri are like moths, fluttering around a dark lantern. They have revealed the anchor that holds the cluster together, and in doing so, they have given us the key to understanding how the universe built its greatest giants. The missing link is missing no more. Thanks for listening to G Fun Facts Online.